question for it's just the part A of the question is to derive the normal form of Green's theorem from derive Green's theorem from the normal form. Here are the two forms of Green's theorem. From the second equation, we may take the left hand side of the equation first. We may assume the vector field F is equal to F1, F2, and the divergence of the vector field. Just look at the third equation. The divergence of the vector field is the partial derivative of F1 with respect to x and the partial derivative of F2 with respect to y. And the union normal vector is dy over ds and minus ds over ds. And we can look at the second equation. We can calculate the line integral. Then we can take F1 F2 is equal to F1 and minus F1 is equal to F2, and we can get the form shown. Then the part B of the question is derive Green's theorem in normal form from the divergence theorem. Here is the equation of divergence theorem. We know divergence theorem is for 3-dimensional and the Green's theorem is for 2-dimensional. So we may assume the vector field F. The k component for vector field is equal to 0, and only I component and j component is F1 and F2. Then we should choose we should come up with surface first. The surface in the xy plane we may choose region R1. And in the plane z is equal to 1, we may choose a region R2, and R1 is just the same as R2. So we can come up with a surface shown in the graph. And the parametric representation of the surface R is equal to xt, yt, and u. Here t and u are just two variables, and u is greater or equal to 1, greater or equal to 0, and less than or equal to 1. And here look at the equation 1. Just here the equation 1. The divergence of the vector field is equal because the k component is 0. So just have two components. The partial derivative of F1 with respect to x and the partial derivative of F2 with respect to y. And dv is equal to dx, dy, dz. And because z is from 0 to 1, so we can calculate the triple integral into a double integral, and z is just 1. And then we may come to the right hand side of the equation. The normal factor, the right hand side of the equation is equal to 3 double integrals over R1, R2, and R3. We know the union normal factor of the surface of the region R1 and R2 is just parallel to z direction, z axis. So the vector field is just in xy plane. So the vector field is a dot product. The normal factor is equal to 0. So the double integral over R1 and R2 is just 0. So the right hand side of the equation is equal to the double integral over R3. And the union normal factor of R3 is x pi, y pi, and 0. I know you know how to calculate the normal factor. So just calculate the vector field f dot product, the normal factor. We can easily have the equation 2 here, and from equation 1 and equation 2 and the previous equation of divergence theorem, we can easily have the answer at the bottom. It's just a normal form of Green's theorem. Thank you.